In this lesson video, this is the question that we're going to answer. Where can we apply the concept of normal distribution? In other words, how does the concept of normal distribution help us in finding the probability of a given situation or study? We're going to perform here the steps in finding the area of the shaded region under a normal curve. So as I told you before, I'll show you and discuss with you the application of it. Para saan ba yung pagkuha ng area ng shaded region under a normal curve? Okay, so here it is. So our learning objectives in this lesson are to convert a normal random variable to a standard normal random variable and to solve problems involving normal distribution. So before we proceed with this, let's have a quick recap. In our previous topics, we have denoted normal random variable by a variable x, and its corresponding raw score is denoted by lowercase letter x. On the other hand, the standard normal random variable is denoted by uppercase letter z, and its corresponding z-score is denoted by lowercase letter z. Don't be confused, class. The uppercase letter x and letter z are representations for variables. Let's say, for example, the number of computers sold in company ABC last Monday is more than 20. So the variable here is number of computers and denoted by uppercase letter x, while the lowercase letters x and z are representations for the raw scores or the values or the z-scores itself. Let's say in this case, the number of computers sold in company ABC last Monday is more than 20. So this is the value, which can be represented by lowercase letter x. So if we're going to write this into mathematical symbols, it's x is greater than 20. Yung lowercase letter x, pinalitan na natin ang mismong raw score. Okay? And yung uppercase letter x, nire-represent niya yung number of computers sold. So to continue, we discuss about the normal distribution. Okay, and it can assume any values for the mean and standard deviation. But a given distribution is considered to be a standard normal distribution if its mean is equal to 0 and its standard deviation is equal to 1. And if the given distribution has a mean of 0 and standard deviation of 1, we can easily find probabilities related to the given situation or study by using or performing the steps that I showed you, that I discussed to you in the lesson video. I am referring to the steps in finding the area of the shaded region under a normal curve. Diba? I already gave you the steps for that. But take note that applicable lang yun kung ang mean ay 0 and ang standard deviation is 1. But the thing is, in many applications, the underlying distribution is not standard. Of course, it is mostly impossible that the mean of all the research studies is always 0 and its standard deviation is always 1. Just like when I asked you to think of a topic for your third quarter performance task in my subject. Diba? Some of your topics are the mean number of family members, the mean number, the mean height, the mean weight, the mean waistline, and so on. So it's impossible for these topics to have a mean of 0. Wala namang 0 na height. Wala namang 0 na weight. Wala namang 0 na family members. Wala namang 0 na waistline. Kaya technically, imposible talaga na magkaroon ng mean na 0 yan. So if that is the case, ma'am, how can we be able to apply the steps in finding the shaded region under a normal curve if it is only applicable to standard normal distribution wherein the mean is 0 and the standard deviation is 1? We have a formula in converting a normal random variable into standard normal random variable, and that is by using this formula. This formula implies that any normally distributed random variable can be transformed to standard normal distribution. Take note of these representations. So I'll just give you only one example in this lesson video. Let me read the problem to you. The mean height of 1,000 students at a certain elementary school is 140 centimeter and the standard deviation is 10 centimeters. So, nag-conduct daw ng survey sa 1,000 students and yung naging resulta ng mean height nitong 1,000 students ay 140 centimeters with a standard deviation of 10 centimeters. Assuming that the height are normally distributed, find the probability of the students whose height are letter A, more than 150 centimeters, and letter B, between 120 and 145 centimeters. So let's have letter A first. So in letter A, you are asked to find the probability of the students whose height are more than 150 centimeters. So if the mean height is 140 centimeters, out of 1,000 students, ilan daw yung probability ng mga students na may height na 150 centimeters and above? In other words, ilan yung porsyento ng 1,000 students ang may height na 150 centimeters pataas? Okay? In order for us to compute for the required probability, we have to convert this distribution into standard normal distribution. Because as you can see there, the mean is not equal to 0 and the standard deviation is not equal to 1. So magko-convert muna tayo. And how do we do that? So we have in step 1, identify first the given. So we have 140 as the population mean. Ma'am, I thought 140 centimeter is just the sample mean. No, kasi wala naman dyan na mention na these 1,000 students are randomly selected from a population. So, yung 140 centimeters daw ay galing na sa 1,000 students na ito. Sa kabuuang number of students na ito. And then, the population standard deviation is 10. And so, we have already the value of mu and the value of this population ST. So we still have to consider the raw score. And in this item, the raw score here is 150. So that's for step 1. Step 2, again, we are asked to find the probability of the students whose height are more than 150 centimeters. So we write it as P of X greater than 150. And we have to convert this to standard normal distribution. So we have to write P of Z, replace X by the variable Z, copy the symbol and replace the part of lowercase letter z by the formula. It's x minus mu over sigma. So, do the substitution. Copy P, copy Z, copy the symbol. The raw score is 150. Subtract it to the given population mean all over 10. Then simplify this. It's 1. Therefore, the corresponding z-score of 150 centimeters is 1. And it means that the raw score 150 is 1 unit above the mean. So let me use a black ink. In step 3, draw the graph. So originally, the mean is 140 centimeter. And ito yung calibration. And since na-convert na natin siya into standard normal distribution, yung katumbas na ni 140 is 0. And since the computed z-score is 1, it means that 150 is 1 unit above the mean. So, nandito pala yung 150. And it is equivalent to the z-score 1. And since the symbol here is greater than, it means that the shaded region should be right here. And that's for step number 3. Step number 4, computation na tayo. Na-convert na natin. So, write the probability of the area that is greater than the z-score 1. So, look at the graph. How are we going to solve for area of the shaded region? We have to use subtraction. Subtract the entire area of half of this normal curve, which is 0.5, to the probability of the area that is between 0 and 1. Copy 0.5, locate 1 on the z table. It's 0.3413. Then get the difference. It's 0.1587. Or in percent, it's 15.87. Okay, therefore, the probability of the students whose height are more than 150 centimeters is 0.1587 or 15.87% of 1,000 students whose height are more than 150 centimeters. So, ganito daw kadami yung may mga height na 150 centimeters pataas. That's for letter A. Let's have letter B. So in letter B, you are asked to find the probability of the students whose height are between 120 and 145. So step 1, identify the given. The population mean is, again, 140 centimeter. The standard deviation is 10 centimeters. And then, since there are 2 raw scores there, magkakaroon din tayo ng dalawang values for x. X sub 1 is 120 and x sub 2 is 145. Step 2, we are going to find the probability of the students whose height are between 120 and 145. So, nagkaroon na ng dalawang endpoint. So, kabilaan na. Again, the smaller value must be placed on the left part of the interval, while the larger value must be placed on the right side of the interval. Then, to convert, we have to write P of z greater than x sub 1 minus mu over st, but less than x sub 2 minus mu is over population st. Then do the substitution. 120 minus 140 all over 10. Then 145 minus 140 all over 10. Simplify this, it's negative 2. Then simplify also this, it's 0.5. So na-convert na natin. The corresponding z-score of the raw score 120 is negative 2, while the corresponding z-score of the raw score 145 is 0.5. So let's draw the graph. So again, originally the mean is 140. Then we have 120 and 145. Since 120 is less than 140, it must be below the mean. So 120 should be put right here, while 145 is greater than the mean, so it must be put on the right side of the mean. So since na-convert na natin siya, katumbas na ng 0 si 140, and then si 120 negative 2, tama nga, nasa left side yung 120. Kasi yung katumbas niyang z-score is negative. So dapat talaga nasa left. Then 145 is equivalent to the z-score 0.5. And then the shaded region must be here between the two endpoints. Then proceed to the computation. Observe the graph. Since the area of interest straddles the mean, we have to use addition. Okay. Add the probability of the area between 0 and 2 and the probability of the area between 0 and 0.5. Ginawa na nating positive sa negative 2 kasi pares lang naman yan. Then locate the z-score 2 on the table. It's 0.4772 plus locate 0.5. It's 0.1915, and then get the sum. The answer is 0.6687, or in percent, 66.87%. So the probability of the students whose height are between 120 and 145 centimeters is 0.6687, or 66.87% of 1,000 students ang may height na between 120 and 145 centimeters. So that's it for this lesson video. Thank you so much for listening.